Hey all, welcome to Homeschool and we are with class 11 chemistry series. Structure of atom is going on. In my previous class, I explained everything about Bohr's model. That's really one of the very important topic for board examination as well as for all the competitive examinations. So it was beautifully explained in a detailed way. So don't miss that video. Go and watch that video for complete clarity on a concept. Video link is provided in the description. I have also discussed about the various formulas that Bohr has given to calculate energy, right? He has given to calculate energy of electron present in a particular orbit. Say we have a formula for total energy, right? And he also gave formula to calculate radius of an orbit, and one more formula we studied, that is velocity of an electron to calculate. Say on these formulas, let us discuss few questions that can come for competitive exams. Say if you know these three basic formulas, you can solve any question. Okay, there are few more formulas to remember which you can derive from these formulas. Okay, so about the formulas, if you want a video, that is also there in a description. It is explained in a detailed way in Bohr's model of an atom, right? Okay, so now let us quickly go for certain numericals, that how they can ask in the examination. See, first and foremost, you must have a general idea about, energy of electron, if it is present in a ground state, first excited state, second excited state, third excited state, and so on. So you should have an idea about what do you mean by this first, second, third, fourth excited states. Okay, now I will give that particular concept. See, and very importantly, all these formulas you can use for single electron systems. Okay, this is very important. So only for single electron atoms or ions you can use his formula. That is the greatest limitations of Bohr's theory actually. So which are the single electron species? Hydrogen atom, single electron species, and then helium plus ion, lithium plus 2 ion, beryllium plus 3 ion. Okay, so you will have questions based on these particles only. Okay, fine. So now the biggest question is calculate energies of electron present in ground state, first excited state, second excited state, third excited state. Okay, so now what do you mean by these excited states? If you take up, okay, of hydrogen atom, see, if you take an atom, if this is a nucleus of an atom, this is hydrogen atom, it will have n is equal to 1. Okay, your electron is there in first orbit. Hydrogen has only one electron. Where is that one electron present? It is present in n is equal to 1. And this shell, we will call it as ground state. This is called as ground state. Okay, then you will have next shell, isn't it? N is equal to 2. This is called as first excited state. Then you will have a third shell, that is n is equal to 3. That is called as second excited state. Okay, so this idea you must have. N is equal to fourth shell is called as third excited state. So this is what we mean by excited state. Okay, so the question is calculate the energy of electron if it is present in ground state, in case if it is present in second state, in case if it is present in third state as well as fourth state. Okay, say assume that it is present in second state. How it can go to second state? When it absorbs energy. Okay, when you give energy from outside, electron can jump to a second level, isn't it? So if electron is present in a second level, what is the energy it should have? Okay, so that is what we need to calculate. So energy of electron or energy of these energy levels or shells is one and the same. Okay, fine. And now we are calculating ground state energy. Okay, if electron is present in a ground state, what is the total energy? Okay, fine. So what is the formula you will use to calculate total energy? You have a formula minus 13.6 Z square by N square electron volt per atom. Okay, if you use this formula, you will get your answer in electron volt per atom. Okay, so the same formula you can use minus 13.6. Okay, Z, what do you mean by Z? Z is nothing but atomic number of element. N is nothing but shell number. Okay, so here for hydrogen atomic number is 1, so 1 square divided by ground state in the sense what? N is equal to 1. Remember, this is really very important. For ground state, N is equal to 1. For first excited state, N is equal to 2. For third excited state, N is equal to 4. Okay, fine. So now we are finding energy of electron if it is present in a ground state. So N value is equal to 1. So 1 square. So you will get the answer 13 minus 13.6 electron volt per atom. Okay, so what is the energy of first shell, guys? It is minus 13.6 electron volt per atom. Likewise, if you calculate energy of first excited state, ES means excited state. If electron is present in first excited state, what is your calculation? Minus 13.6 into atomic number of hydrogen is 1 square. Now what is the value of N? For the first excited state, value of N is equal to 2. So it is 2 square. So it is 13.6 divided by 4. So you will have 3 minus 3.6 or 5, 3.6 electron volt per atom. Approximately I will write minus 3 okay, let me take it as 5 electron volt per atom. Okay, so likewise for second excited state, okay, when you find answer, what do you get? It is minus 13.6 into 1 square. For second excited state, what is the N value? It is 3, right? So 3 square, that is 9 if you do. You will get the answer minus 1.5 electron volt per atom. So what is the energy of this particular shell? I mean, if electron is there in this shell, what is its energy? It is minus 1.5 electron volt. Okay, likewise when you calculate for third excited state, okay, minus 13.6 into 1 square by N is equal to 4, that is 4 square if you do, you will get the answer minus 0.8 electron volt per atom. Right, so here what do I take? Minus 0.8 electron volt. Likewise, for N is equal to 5, when you calculate, you will get minus 0.5 electron volt. Right, so actually it is better if you can remember these values of hydrogen atom. Okay, say if you can remember these values, your calculations further will become more easy. So I recommend you to remember energy of energy of first shell or the ground state is minus 13.6. Energy of first excited state is minus 3.5. If an electron is present in second excited state, energy is minus 1.5 electron volt. Then if it is present in third excited state, answer is minus 0.8 electron volt. Okay, so I recommend you to remember these values, right? Okay, so now I will go for one more question. See, this is a very basic question. Okay, so you can use this formula to calculate. Especially for the hydrogen atom, it is better to remember these values. Now let's go for one more question. Look at this question, guys. Calculate energy of electron present in first excited state of say He plus ion. Okay, so you have to find energy of electron present in first excited state. Can you tell me what do you mean by first excited state? See, N is equal to 1. First shell is called as ground state. N is equal to 2 is called as first excited state. Okay, fine. So total energy they asked you to find out now. So what is the formula? Total energy is equal to minus 13.6 Z square by N square electron volt per atom. Okay, so if you substitute the value of Z and N here, minus 13.6 into Z square, what is the atomic number of helium? Z is equal to 2. Atomic number is 2, right? So Z value is 2. So 2 square divided by N. So first excited state means N is equal to 2, right? So it is 2 square. So 2 gets cancelled. So minus 13.6 electron volt per atom. Okay. So this is the answer you will get. Right? So for the energy of first excited state in case of He plus ion. Right? Okay. See, this is how you can use this particular formula for any one electron species. So you just have to be careful with Z and N. Okay, so Z is atomic number, N is equal to shell number. So they would mention words something like this: first excited state, second excited state, and third excited state. You must know their meanings. Now let us go for another question. Here I'll tell you one more important formula. Question number 3. Calculate ionization energy. Ionization energy of electron present in hydrogen atom. Okay. See, first try to understand what do you mean by ionization energy. It is the energy required to remove the electron out of the atom is called ionization energy. Okay, it is the energy required, okay, to remove the electron out of the atom is called ionization energy. That means, see, in our hydrogen atom, electron is there in N is equal to first shell. Here electron is there. If you have to remove this electron, you need to supply some energy. Say, where will this electron goes after removing? It may go to N is equal to infinity level. Okay, it may go to N is equal to infinity. So how much energy is required to take out electron from N is equal to 1 to N is equal to infinity? It is this much energy difference. Okay, right. So here delta E is equal to E2 minus E1. Okay, what is E2 infinity? Delta E is equal to energy of infinity level and energy of first level. And energy of infinity level is always 0, isn't it? Minus, what is the formula to calculate energy of an electron? Right? It is, we know the formula, minus 13.6 Z square by N square. Right? So minus into minus, delta E is equal to minus into minus plus 13.6 Z square N square electron volt per atom. So this much energy. So the difference, energy difference between first level and infinity level, that much energy is required to remove the electron from first orbit. Okay, removing it from atom completely means what? Removing, and it is going to infinity level. In infinity level, its energy is 0. Okay, so this is the formula you can use to calculate IE, that is ionization energy. Okay, so that's what, just in sign you have a difference. Energy to calculate for an electron present in a particular orbit, that is total energy to calculate, is this formula, minus will come. Whereas if you want to calculate ionization energy, it is this formula same, total energy minus sign, ionization energy plus sign. Okay, so now you calculate here, what is that? It is the same formula, ionization energy is equal to plus 13.6 Z square by N square. Remember this formula. Okay, so now they asked you to calculate for hydrogen atom, no? So 13.6, Z value for hydrogen is 1 square, Z value for, N value, your electron is present in N is equal to 1 shell. So it is 1 square. So ionization energy of hydrogen is 13.6 electron volt per atom. Okay. Say in case if the answer is asked in joules, what do? You will convert electron volt into joule. What is the conversion? 1 electron volt is equal to 1.6 into 10 power minus 19 joule. Okay, so they can answer even in joules also. Then this is the conversion factor you can use, right? Okay, so now we will go for little advanced question that they can ask for competitive exams. See guys, our next question, let it be the ionization energy of hydrogen atom is 13.6 electron volt. Just now we calculated also, right? Okay. So giving this, and they'll ask you calculate ionization energy of Li plus 3 and He plus 2. Okay. So this is how they'll ask you the question. See, it's very easy. First, let me calculate ionization energy of He plus 2. So you can just simply use, there is a formula, ionization energy of hydrogen into Z square. Okay, Z square if you use, then just you can calculate ionization energy of He plus 2. So ionization energy of hydrogen is given, right? It is 13.6 electron volt into Z square. What is Z here? Z is atomic number. Okay. So what is atomic number of helium? Atomic number of helium is 2, right? So 2 square you have to do. That is 13.6 into 4 you should get. Okay. So these many electron volt per atom. Right? So whenever they ask you giving some ionization energy of some element, and when they ask you to calculate ionization energy of other elements, okay, then you just have to do ionization energy of given element into Z square. So this Z value is for the element that you are calculating. Okay. So similarly, if I have to calculate ionization energy of Li plus 3, okay, then what is the formula I can put? It is nothing but ionization energy of hydrogen. Okay. So into Z square. So its value we know, 13.6, it's given, right? It's not that you have to remember. Into Z square. What is Z value for lithium? Atomic number is 3 for lithium, no? So it is 3 square. That is 13.6 into 9 you can do. Okay, so these many electron volt per atom. Okay, say one more question similar to this I'll frame. So this is the question number 4 we discussed. Now the question number 5 you see, ionization energy of let me take He plus 2. Okay, is let it be 19.5 6 into 10 power minus 18 joule per atom. Okay, so He plus 2's ionization energy is this much. Calculate ionization energy of say for example, sorry, He plus, here it is Li plus 2. Then what do you do, guys? It is ionization energy of Li plus 2 is equal to this value. This value is given, no, this value into Z square, that is 19.6 into 10 power minus 18 into Z square. So what is Z square for lithium? Atomic number 3, no? So 3 square you should do. 3 square, that is 9 into this value you should multiply. So you will get answer in joule per atom, because the given value was in joule per atom. Okay, so this is how some questions can be asked on competitive examinations. See guys, look at this question where I need to use the formula of radius. Okay, see, question can be like this. Calculate radius of first energy level in hydrogen atom. Okay, so what is the formula that we learned for radius? Radius is equal to 0.53 n square by z angstrom. This was the formula, right? So what did I tell you? To calculate radius of first shell, that is first energy level in hydrogen. So substitute 0.53. First one, n is equal to 1, that is 1 square. Z value for hydrogen is 1. So it is 0.53 angstrom. Okay, radius of first orbit of hydrogen atom is, 0.53 angstrom. And this value is very, very important. And this value we will call it as Bohr's radius. Okay, Bohr's radius. So very important. It was asked in one of the question papers of NEET. Okay, so which one is called as Bohr's radius? 0.53 angstrom. This value itself is called as Bohr's radius. And if you want to talk about this value in picometer, it is 52.9 picometer. In case of picometer, it is this much. In case of angstrom, it is this much. Okay, now on the radius itself, one more question, that is calculate radius of third energy level in Li plus 2 ion. Okay, then also same formula you can use, that is R is equal to 0.53 n square by z only, right? So 0.53 into third energy level, that is n is equal to 3. So 3 square divided by z value for lithium. Lithium's atomic number is 3, right? So 3. So this is how you need to calculate. You get the answer in angstrom, right? So this is how for other single electron species also they can ask. So concentrate here, what is the n value and what is z value. Okay, sometimes they will mention radius of first excited state, radius of second excited state. Then excited state means you must know the meaning. Okay, first excited state means n is equal to 2, second excited state means n is equal to 3. That you have to substitute and calculate. And the next type of questions on Bohr's model is on velocity. Okay, so they'll ask you to calculate velocity of electron in single electron species. Remember, all these formulas are true only for single electron species. Okay, say velocity formula, V is equal to 2.18 into 10 power 6 Z by n meter per second. Right, so they'll ask you calculate velocity of electron in second excited state of Li plus 2 ion. Say same formula. How do you substitute? 2.18 velocity of second excited state in lithium, right? So 2.18 into 10 power 6. Z value for lithium, atomic number. Z means atomic number, that is lithium it is 3 divided by N, second excited state. N is equal to 1 is called as ground state. N is equal to 2 is called as first excited state, right? N is equal to 3 is called as second excited state. So second excited state means N is equal to 3. So 3 by 3. This gets cancelled. So your answer is 2.18 into 10 power 6 meter per second, right? So this is how problems can be asked on, total energy, can be asked on ionization energy. It can be asked on radius as well as on velocity. Okay. See, I have shown you some basic problems on Bohr's model, right? So very, very important. And in my next class, I will come up with hydrogen spectrum and calculations relating to hydrogen spectrum. So there I'm going to tell you many shortcuts in calculation. So do watch the next video also. Thank you so much.